Welcome to this video of the Understanding Gradle series. Today we will talk about tasks which you need to run Gradle builds. Let's get back to the example project we've introduced in previous videos. This time we will focus on the app subproject as an example of one subproject we run tasks in. At the moment the build file of the project is empty. If we ask Gradle to show us the tasks that are available to run builds, we can see that there are only a number of help tasks available. This is because the core of Gradle only provides these tasks to analyze your build. Other tasks to actually build your project are as many things added by plugins. Let's start exploring this by adding the base plugin, which is a Gradle core plugin that adds some central lifecycle tasks. We can see that now the assemble and the build tasks are available. If we run the build task, which we address by the name of the subproject and the name of the task separated by colons, we see that not much happens. It's important to know that Gradle distinguishes between two types of tasks: lifecycle tasks and actionable tasks. What the base plugin adds are only lifecycle tasks. Lifecycle tasks define targets you can call, like telling Gradle to build your project. The base plugin, however, only adds these lifecycle tasks without wiring any actionable tasks to them. Such actionable tasks are added by plugins like the Java Library plugin, which provides tasks for things like compiling Java source code or packaging classes into a jar. We can see that more tasks became available now, and not shown here, more actionable tasks were wired to the lifecycle tasks. So if we call the build task now, we can see that several tasks have been executed, including the compile Java task. An important aspect of Gradle tasks is their incrementality. Gradle can reuse results from previous builds. So if we already did build our project and only change a small thing, running build again will not cause a lot of work. For instance, if we only change test code in our example, but not production code, running the build will only recompile test code, but not the production code, which is marked as up to date by Gradle. Gradle is also able to reuse results from history. For this, you need to enable the build cache, which you can do via the build cache command line parameter or by setting a property in the Gradle properties file. This can speed up your builds a lot. For example, if you switch between branches regularly. The build cache can also be located on a remote server and shared between multiple machines. With this setup, the CI server can populate the build cache and multiple developers can reuse the results. It's important to realize that Gradle knows the dependencies between all tasks. By this it knows, whichever task you target, what other task it needs to execute. Let's add a dependency to our app subproject. The app project now depends on our other two subprojects, directly on the business logic project and indirectly on the data model project. If we now run build again, we also see how the Java code of this project is compiled. Let's turn our app into an actual application by applying the application plugin instead of the Java Library plugin. We can see that more tasks have been added now. Among them is a run task, which we can use to run the application. If we call the task and everything is up to date, the application will start immediately. If not, only things that have been changed will need to be rebuilt by Gradle. With the knowledge from this and the previous videos, you are now able to set up a standard Java project and build it. In the next videos, we'll talk about how you can address more individual concerns of your projects by defining your own tasks. Please remember to subscribe to this channel and leave questions or suggestions in the comments. See you next time.